Right. Let's begin by setting the stage for what this subtopic is about. We have all used computers and smartphones through graphical user interface or GUI for decades. This interface rely on buttons, icons, menus, and touch gestures. But with the rise of large language models like ChatGPT, we are witnessing a major shift from GUI to natural language interfaces. In other words, we are moving towards interacting with technology through conversation, just like we talk to another person. One of the most powerful and well-known examples of this shift is ChatGPT. It has become a benchmark product that shows how consumer-facing large language models can make advanced AI feel simple and useful, even friendly. This shift changes the rule of the game for HCI, human computer interaction. We are no longer just clicking things, we are talking, we are asking, and we are getting meaningful responses. Human large language model interaction is now a new paradigm, one that we need to study seriously because it affects design, behavior, and user expectations. The big goal in this space are make the experience intuitive so that people can just talk to the system naturally, keep it safe so users don't receive harmful and misleading responses. Ensure it's adaptive, meaning it tailors itself to different users and tasks. And of course, it should be productive, helping users get real work done. One fascinating thing about large language models is that they function not just as the intelligence engine behind the scenes, but also as the interface itself. That's a big deal in HCI. It blurs the line between what we see and what the system knows. So we will break down the key pieces of how these systems work. We will look at their features like context handling, memory, summarization, and how orchestration layers tied in all together to produce the smooth experience we see in products like ChatGPT. Now let's dive into the user experience philosophy behind ChatGPT. At the heart of it, it's the idea that natural conversation is a universal interface. You don't need to learn how to use it the way you learn a new app or software tool. You just talk or type like you'd with another person. This lowers the barrier for entry for everyone, whether you are tech savvy or not. That brings us to the second point, low friction. There's no learning curve here. You are not navigating menus, dragging icons, or configuring settings. You simply start with a question or a request, and then the system responds. That's a major design win in HCI. When the user doesn't feel like they are learning a tool, they feel they are just communicating. Next, ChatGPT was intentionally designed for a wide audience. It's used by students doing homework, professionals automating tasks, and creators brainstorming ideas. That range make it one of the most broadly accessible AI tools ever created. The design had to support that versatility while still feeling consistent and approachable. Another key philosophy is the balance between visual simplicity and back-end complexity. What you see here is just a clean chat box, but under the hood, there's a massive language model, safety systems, memory logic, and more. The goal was to make something powerful feel simple without exposing users to that complexity. And finally, one of the reasons it works so well is because usability is constantly improved through feedback. The team doesn't just guess what people want, they learn from what people do. This is where HCI plays a central role. Every upvote, every mistake, every suggestions help shape the next version. It's a loop of design, testing, and real-world learning. So, in summary, ChatGPT's user experience isn't just a lucky accident. It's the result of intentional design choices, deeply informed by modern HCI principles and powered by AI in the background. These slides get into the engine that powers adaptive intelligent interaction large language model. Specifically, we're talking about the GPT models that power tools like ChatGPT. So first off, ChatGPT is built on top of a series of GPT models, starting with GPT-3, 3.5, then 4, and GPT-4 Turbo, GPT 4.5, 4.0, 0.1, 0.3, 4.1. So you can see the interesting naming convention by OpenAI. They have GPT 4.5 first and then 4.1. These are the brands behind the system trained on huge amounts of text from the internet and fine-tuned to have helpful conversations. At the core of these models is something called the transformer architecture. This is what gives the model its ability to understand sequences like a paragraph, a conversation, or even codes. The transformer checks relationships between words and meanings across long stretches of texts. This makes it excellent for understanding the flow and intent of what someone is saying. What makes this model powerful in an HCI context is that they support few shot and in context learning. That means you can show the model just a couple of examples or even just one, and it can adapt immediately without being retrained. It's like teaching someone a task on the fly and having them pick it up instantly. And the way we talk to these models is through prompt design. Think of prompts as the new programming language of interaction. If you write your prompt clearly and with intention, you can shape the model's response significantly. So prompt design is becoming new HCI skill, like designing a UI, but with words instead of buttons. These models also show something remarkable, emergent reasoning ability. That means they can do things like solving puzzles, summarizing ideas, or make inferences, even if they weren't explicitly trained for it. That open up huge opportunities for interaction design because now you can rely on the model to understand a wide range of context without a rule book. And finally, from a deployment point of view, this is all zero in store and multimodal. You don't have to download anything. These models can handle text, code, images, and even upload files, all in a single conversational flow. That make it incredibly versatile and user friendly for many applications. So large language models don't just process input, they adapt to users, supports flexible tasks, and creates new possibilities for interaction across domains and formats. All right, let's now talk about one of the most important parts of making a LLM like ChatGPT feel intelligent and human-like. It's called context management and memory. First, let's start with section context. ChatGPT doesn't just respond to your last sentence, it looks at the whole conversation you have had in that section. That way, it can answer follow up questions, remember what you just asked, and maintain a logical flow. Without these kinds of short term memory, the interaction would feel fragmented and robotic. But this comes with a limit, literally. The model can only see a certain number of tokens at once. A token is basically a chunk of text, like a word or part of a word. So if a conversation gets too long, the system has to truncate the beginning. This means it might forget earlier parts unless memory features are used. So developers have to decide what gets cut and how to manage that invisible window of attention. To get beyond that short-term section, ChatGPT now offers persistent memory, but it's opt-in. When memory is turned on, the model can remember things across sections like your name, your tone preferences, or the kinds of help you typically ask for. That start to feel more like a personal assistant, which is a major step forward in HCI. This memory enables continuity. You don't have to reintroduce yourself every time. The system can greet you by name or follow up on project you mentioned last week. That makes the experience feel a lot more natural and user friendly. But there's a trade off here with memory. You get convenience, but you also give up some control. So there's a tension between um, of um, ephemeral context, which disappears after a section, and persistent memory, which sticks around. Users need to be able to decide what's remembered and what's not. And that brings up us to a core HCI challenge. How do we balance utility with privacy and transparency? Users want smart systems, but they also want to know what's being stored and why. If we hide too much, we lose trust. If we expose too much, we create confusion or overwhelm. So part of designing great HCI in LLM is building interfaces that clearly show users what the system remembers and let them control it. So memory is powerful, but it's also personal. How we design around that define. Now, this is a really important concept to understand. The large language models like GPTs are fundamentally stateless. That means on their own, they don't remember what you said 10 minutes ago or even one turn ago. Each prompt is processed in isolation unless we manually add context back in. This is where the orchestration layer becomes essential. Think of it like the brain behind the scenes. It's not the model itself, but the logic that handles memory, history, and user specific data. By keeping section memory or persistent user memory, the orchestration layer can enable the assistant to remember your name, recall your preferences, or refer back to something you asked earlier in the section. That's how these interactions start to feel truly personal and fluid. The orchestration system retrieves the right past information like previous user messages or preferences and then inject that into the prompt is sent to the large language model. So even though the model itself is forgetful, the system makes it feel like it remembers. We often distinguish between short-term memory, like what's remembered during a single section, and persistent memory, which is remembered across sections. Persistent memory might store that you prefer concise answers or that you are studying for an HCI exam and bring that up later. From an HCI perspective, this enables continuity and coherence, which are huge for usability. But as we discussed in the previous slide, there's also a trade-off here. Users need transparency and control. So most systems give users options to turn memory on or off, delete it, or see what's stored. So memory isn't just about convenience. It's fundamental to make AI assistants feel intelligent, consistent, and human aware. This is the heart of adaptive interaction design in the large language model era. Now we are moving to a critical distinction in modern LLM-based interface design. The difference between prompt engineering and context engineering. Let's start with prompt engineering. This is the art and science of crafting effective inputs, also called prompts, that guide the LLM behavior. At, at its core, prompt engineering focuses on clarity of language, task framing, and few short examples. So the more precise your instructions, the more accurate and useful the response. And task framing means telling the model what role to play, like saying you are a helpful tutor or act like a travel agent to guide tone and style. Instead of retraining the model, you simply show it a couple of examples right in the prompt, and it generalizes from that. Prompt engineering is usually status. It only works for the current request or section. Once the section ends or the model's context window runs out, that prompt is gone. So it's best for one-off tasks or shallow interactions where context doesn't need to persist. Now contrast that with contextual or context engineering, which is more about designing how information persists and evolves over time. This includes maintaining memory, section history, and user preferences across interactions, creating personalized experiences that build up over multiple sections, and modeling user intent so that the system can predict what the user might need next. Context engineering is all about statefulness. You are architecting how the system remember things, not just what they respond to in the moment. That could include building memory slots for user names, project history, prior queries, or even interaction styles. A simple analogy, prompt engineering is like giving a smart assistant very clear one-time instructions, and context engineering is like training that assistant to work with you every day, remember your habits, and anticipate your needs. So when we say prompts, it's like one-shot instruction. Context is like dynamic and evolving state. We are pointing to the difference between temporary command versus persistent personalization. Both of these are essential for designing robust LLM-powered interfaces. Prompt engineering gives you the precision and control to shape interactions immediately. Context engineering enables long-term intelligence and continuity. Together, they help make interactions more adaptive, efficient, and human-like. As we move forward, we will see more hybrid systems that integrate both, where prompts are dynamically generated based on context, and memory helps shape prompts behind the scene. Next up, let's talk about two techniques that are essential for making LLMs efficient and usable at scale: chunking and summarizing. We'll start with chunking. When users input long documents, think entire reports, long emails, or even code bases. Large language models can't always handle them in one go due to token limits. Remember, models like GPT-4 can or GPT-4o can only process a fixed number of tokens in a single prompt window. So to manage this, the system breaks the input into chunks, smaller, manageable pieces of content that can be processed independently. This automatic breakdown isn't just cutting text randomly. It's often done using smart heuristics, breaking at paragraph or sentence boundaries, or by semantic units in code. This ensures the pieces still make sense when analyzed individually. Then we have internal summarization. When there's too much content to fit into the token windows, models or the orchestration system may generate internal summaries of previous terms or large inputs to preserve context while saving space. This is especially useful for multi-term conversations when the system wants to remember the past without exceeding the input limits. Also, another technique is real-time summarization. As you interact, the model may summarize ongoing dialogue behind the scene to prepare for the next output. This is key for things like planning a response that draws from multiple topics or balancing tone, intent, or length in answers. For document-intensive user cases like document Q&A, we now use vector stores and retrieval augmented generation RAG. This means we chunk the documents and then embed each chunk into a vector, which is a mathematical representation. And then when a query is asked, we search the most relevant chunks and feed them into the model to generate a grounded, context-aware response. So instead of sending the whole document to the model, we send just the relevant pieces that keep things fast, cost effective, and focused. All these techniques, chunking, summarizing, retrieval, play a huge role in improving usability, efficiency, and relevance. Users don't notice the complexity, they just get better answers faster. So, in short, chunking and summarization are the invisible gears that help LLM based systems scale to real world cases, especially when dealing with long, long form content or multi step um, tasks. Now let's talk about how roles and system prompts help structure intelligent interaction with large language models, especially in agent-like systems. First, we have role definitions. These are essential in shaping how the assistant behaves. Think of it like assigning a job title to the AI. Are you asking it to act as a grammar checker, a coding tutor, a creative writer, or a medical assistant? The role you assign gives structure to how it responds. This is a critical principle borrowed from human computer interaction, where context and framing deeply influence usability. Now, one way to define a role is through the system prompt. This is a hidden instruction that sets the tone and boundaries for the AI behavior across the section. You can think of it as a sort of meta persona, while the user prompt changes with each question. The system prompt stays steady and governs the assistant's core identity, whether it should sound professional, casual, empathetic, cautious, or even humorous. Then we get into multi-role scenarios, which are increasingly common. For example, you might want the assistant to switch between being a brainstorming partner, a grammar checker, and a fact checker, all in one conversation. This flexibility in role shifting enables complex workflow within a single section without having to start from scratch each time. We call this persona switching, and it's becoming more popular, especially in consumer products where users want more tailored experience. A good example is switching from a friendly tutor persona to a no-nonsense code reviewer, depending on the user's goal at the moment. Now, there are two main technical strategies for defining role behavior. One is fine-tuning, another one is prompt engineering. Fine-tuning means retraining the model on role-specific data. It's expensive and less flexible. Then prompt engineering is cheaper, faster, and easier. Most consumer-facing systems today rely on prompt engineering for persona and role control because it's more adaptable in real time. Finally, these roles allow us to design interaction flows with agentic behavior. Instead of just answering questions passively, the system can take initiative, offer suggestions, or even ask clarifying questions, all based on its assigned role. This is where agentic design starts to feel less like a tool and more like a collaborator. So, to summarize, role based prompting is a fundamental tool in modern HCI with LLMs. It blends personality, function, and responsiveness to give users more natural, goal aligned experiences. Now, let's also look at an often invisible but absolutely critical layer of LLM based system moderation and safety. To start, one of the foundational tools here is the OpenAI Moderation API. It's a system that scans and flags harmful contents, whether it's coming from the user or being generated by the model. This isn't just a filter, it's a safety net designed to catch content that's offensive, dangerous, or violates ethical norms. What's powerful about this system is that it operates across multiple stages. It can scan the prompt before it's sent to the model. It can monitor the input and ongoing conversation, and it evaluates the output too, making sure what the model says back is safe, responsible, and appropriate. Moderation systems are trained to detect a range of risk categories, things like hate speech, threats of violence, sexual contents, and anything related to self harm or suicide. These categories reflect both platform policies and broad social standards for safe digital environments. There's also a split in where moderation happens on device versus cloud based. On device moderation is faster and more private, but limited in complexity. Cloud moderation, like OpenAI's, is heavier duty. It can evaluate more context and apply dynamic updates in high risk or enterprise setting. Hybrid models are often used, but beyond just technical filtering, moderation has a huge impact on trust and accessibility, which ties directly into ethical HCI. If users don't feel safe, or if the system fails to block harmful content, trust evaporates. But over filtering can make people feel censored or limited, especially in diverse cultural contexts. So there's a balance, designing moderation that's strict where it matters, but flexible enough to allow honest, productive conversation. A critical part of this loop is user feedback. Modern safety systems increasingly rely on signals from users, flagging inappropriate output or giving thumbs down. This feedback helps improve detection models, retrain risk classifiers, and refine edge cases. In short, moderation isn't static, it learns over time. So, moderation and safety layers aren't just a back end detail, they are front and center in how we build ethical, scalable, and human-centric LLM applications. They affect not only what the model can say, but also how users feel when interacting with it. Now let's explore one of the most powerful but often hidden components of modern LLM-based system, the orchestration layer and how it coordinates tools. So when we interact with ChatGPT, we're not just dealing with a raw LLM anymore. There's a sophisticated orchestration layer in the background that handles memory, retrieval, and tool usage. Think of this like a backstage crew making sure everything runs smoothly on stage. The model may appear to just be answering your questions, but under the hood, it might be assessing documents, analyzing files, generating images, or running code all in real time. One key concept here is RAG, retrieval augmented generation. This is a strategy where the model retrieves relevant documents or data and then generates responses based on that retrieved context. It helps the model stay grounded in real world facts, especially for enterprise use or technical queries. Now we have the tool ecosystem, things like the code interpreter, file analysis, DALL-E for image generation, and web browsing. These tools are not baked into the LLM. They are invoked dynamically when the situation calls for it. This requires tool switching, where the model figures out which tool to call, when, and how to present the result in a human-friendly way. To make it possible, we rely on agent-like routing logic in the background. These AI agents don't just wait passively for input. They access the task, choosing the right tools, and sometimes even chain them together. For example, to answer a data question, it might download a CSV, runs Python code on it, and summarize the result, all without using any of that complexity. From an HCI standpoint, this is huge. The orchestration layer allows us to deliver a very simple UX. You type a question, but behind the scene, there's complex orchestration logic creating that seamless experience. This is the magic of modern conversational interface. High-level simplicity supported by deep technical plumbing. And finally, this orchestration follows a layered architecture, meaning it's modular and customizable. Developers can plug in new tools, route tasks differently, or swap in new memory systems. This extensibility makes it incredibly powerful for research, enterprise, and consumer-grade applications. What feels like a simple conversation with a chatbot is actually a highly coordinated act across memory, tools, and task logic made, made possible by the orchestration layer. Let's wrap things up by talking about some UX challenges and opportunities when designing with LLMs. First, there's the challenge of managing user expectations. These models sound confident even when they are wrong. This is what we call hallucination. When the model generates text that looks plausible but isn't true, so users might ask a question, get a polished response, and just assume it's correct. This creates a mismatch between what the system can do and what the user think it can do. That brings us to the next big issue, explainability and transparency. Why did the model give that answer? How was it generated? In traditional software, we have rules and logs. In LLMs, the reasoning is statistical and opaque. So, as designers and researchers, we need to think about how we give users just enough insight to trust the system, but not so much technical details that it becomes overwhelming. Now, here's the interesting design tension. Do we teach users prompt engineering? How to get better result by crafting better inputs? Or do we try to hide that complexity completely? Some people want full control, others want it to just work. So there's a trade-off between power and simplicity in interface design. Another area that is rapidly evolving is multimodal input and output. LLMs like GPT-4o can handle images, text, code, documents, and even speech. That opens up a lot of creative possibilities, but it also raises UX questions. How do we design an interface that works equally well with a voice command, a photo, and a typed query? So, of course, there's always ambiguity and error handling. These systems will misunderstand users sometimes. The key is how gracefully they recover. Can the assistant clarify what you mean? Can it suggest alternatives? Good UI, good UX here is about error recovery, not error elimination. Lastly, one of the hardest problems is what we call trust calibration. Users shouldn't blindly believe everything the model says, but they also shouldn't ignore it entirely. The goal is to hit a sweet spot where users use the model as a helpful tool, but still apply human judgment and critical thinking. So as we design this system, the challenge isn't just making them smarter, it's making them usable, trustworthy, and adaptable for real people in real world contexts. So let's bring it all together. When we look at ChatGPT, we are not just looking at a chatbot. We are looking at a prototype of the future of HCI. It's a system where we don't have to click, tap, or scroll to get something done. We just talk like we do with another human being. That's a huge shift from traditional GUIs. And here's the key. ChatGPT isn't just about the raw power of a large language model. It's the orchestration layer that turns that raw intelligence into something usable, safe, and responsive. It manages memory, handles tools, route tasks, and it does all of that quietly in the background, so users get a seamless experience. Looking ahead, we are headed into a world of agentic interfaces where a system don't just wait for command, but take initiatives. We will see more voice-first interactions, more personalized context, and systems that evolve with the human over time. This isn't just about pressing buttons anymore. It's about systems that behave, adapt, and even collaborate with us. So the role of the HCI designer is changing. We are moving from designing interfaces, what's on the screen, to designing behaviors. What should an AI respond? When should it speak up? When should it step back? And ultimately, designing HCI in the LLM era is about designing cooperation. We are building interfaces that are no longer passive tools, but partners in thoughts. That's a real big responsibility and really exciting frontier.